Hello friends, in today's video we are going to rotate the servo motor from 0 to 180 degree with the help of this MPU6050, right? And when the MP is at level surface, the servo is at 90 degree. And I will also tell you that why you should power the servo motor with external battery supply, like I am using here. So let's get started. Now let me give you a quick brief about the circuit connections. So you can see the SCL pin of the MP is connected to pin number A5, right? You can see this blue wire is connected to A5 and SDA pin is connected to pin number A4 because Arduino and MPU6050 are communicating with each other using the I2C protocol. So the I2C protocol uses two wires, SDA and SCL. SDA stands for serial data and SCL stands for serial clock. So on the Arduino only two pins are there, A4 and A5, which are used for I2C communication. And obviously the ground and the VCC pin of the MPU are connected to the ground and the 5V pin of the Arduino respectively. Now the thing is, how should we power the servo motor? So I am powering the servo motor using an external battery supply, and I will also give you the reason why we are doing this. Now the thing is, the servo motor works at only 5V. If you provide greater than 5V, it may damage. So to step down the voltage from 12V to 5V, I am using a voltage regulator IC here, which is LM7805, which is the same as this IC, right? So this IC and this IC is the same. So at the left terminal of this IC, we will provide an input of 12V. This middle pin is for the ground and this right terminal is for the output of 5V. Okay. So you can see this orange wire is connected to the anode of the battery and this green wire is connected to the ground, which means negative terminal of the battery. And this yellow wire is the 5V output. So this yellow wire is connected to the positive rail of the breadboard and this green wire is connected to the negative rail of the breadboard. And using these rails, I am powering the servo motor. You can see this middle terminal is a VC, so this blue wire is connected to the positive rail, right? And this brown wire is connected to the negative rail. And this signal wire is connected to the digital pin 6, which is PWM supported. Now one important point to note here is that we should provide a common ground between the Arduino and the battery, and it is a recommended practice. So you can see this black wire here is doing the same job. One terminal is connected to the ground and other terminal is connected to the negative rail of the breadboard, which is directly connected to the cathode of the battery. And it's not the case that if you don't provide a common ground, your project won't work. No. But if you don't provide common ground, what would happen? The values that you will get from the MP6050 won't be smooth. They will be messy, right? So we can't use those values to move this servo motor. So that's why you should provide a common ground between both of them. Now let me give you the reason why you should power the servo motor using external supply. Okay. So suppose you have connected the servo and the MPU with the Arduino and you are powering this Arduino to the laptop using the USB cable. So first thing you need to know that the standard USB port can only provide a maximum current of 500 to 600 milliampere, right? But during starting of the servo motor, it can draw a maximum spike of current around 600 to 800 milliampere. So the model that I have here is SG90. But if you choose higher models like MG90 or MG995R, they can draw even more current. Okay, and Arduino itself requires some amount of current for its proper working. So it can draw around current of 50 milliampere. So the total current requirement for this project is 850 milliampere. I am ignoring the current requirement for this MPU for a while because it can draw current of around 5 to 8 milliampere. So it is negligible. So the total current requirement for this project is more than what the USB port can provide, right? So that is why we should provide an external supply for the servo motor. Now before moving further, if you want to know more about why Adafruit library fails for clone MPU6050, then you can check out this video. In this video, I have explained the complete reason why Adafruit does not work with clone MPU6050. Now coming back to our topic, I am importing the wire library for I2C communication, servo.h for servo motor and MP6050 Lite for calculating the angle from MPU. And I am also defining servo object and MPU object, right? And this is a timer variable. Now in the setup section, this 9600 is the baud rate and this wire.begin is used for the initialization of I2C communication between the Arduino and MPU. And servo is connected to pin number 6, which is PWM supported, right? And we are also defining MPU.begin. So this status will be 0 or 1. If the status is equal to 0, it means the communication between the Arduino and the MPU is established. And if the status is equal to 1, it means there is some error between the communication. And we are also calibrating the MPU. So this line is printing calibrating and keep the sensor still. So here we need to keep the sensor still. Now this line is very important, MPU.calculate offsets, right? So you need to know that the MP6050 is not perfect. So even though the sensor is lying on a perfectly leveled surface, some error will be there. Suppose the acceleration due to gravity is 1 times g, so the accelerometer might read 0.98 g, 0.99 g, 1.1 g and something like that. And the gyroscope might read the sensor is rotating by 0.5 degree per second, 1 degree per second, right? So these values are not perfect. So the job of this function calculate offset is to calculate and eliminating those errors. Now in the loop function we are updating the MP using mp.update. So we need to account for each and every value of data every single time. That is why we need to update the MP in the loop function. And we are rotating the MP about the x-axis and storing the angle in the angle x variable. And we are mapping the angle x from -90 to +90 to this range 0 to 180, right? And we are considering the servo value in the range 0 to 180, and we are writing the servo value on the servo motor using myservo.write. Now we are printing the values of servo and the angle using this if condition. If millis minus timer is greater than 100. So millis gives you the time since the Arduino starts to run, and timer is the current time, right? So if this difference between the current time and the previous time is greater than 100, then we are printing the values, otherwise not. And we are also updating the timer variable with the millis. Now you may ask why we are using this if condition for printing the values on the serial monitor. So suppose if this condition were not there, then in that case the values of the printing of the values would be too fast, and our eyes won't be able to catch those values. So that is why it's necessary to use this condition. Now instead of this if condition, I could also use a delay function here. So let me comment out this if condition and adding a delay of 100 milliseconds. So what does this delay function do? It will completely shut down the working of Arduino Uno microcontroller. Okay. And suppose the MP6050 moves for this 100 millisecond time interval, then we won't be able to get those values. So we would miss their data, right? So that is why delay function is not desirable here. So I'm not using this here. Only the if condition is feasible here. Okay. So that's all for this project, and if you enjoyed this video, then make sure to subscribe to my channel and share this video. And if you have any doubt regarding this project, comment in the comment section, and I will meet you with the new project in next video.